getting some love in the, all right, cool. Good. So let's get this moving. We're going live. And it is super good to be back. Welcome everyone to the Data on Kubernetes community. After a brief hiatus, we are back in full force with tons of live streams. We're getting close to live stream number 100. We're at live stream 98 because of some changes in other live streams that we added between when we scheduled this with Neil and when we're having it. We see 96 and 97, but this is in fact live stream number 98. We are getting close to number 100. Very stoked about that. Couple of updates just for folks that are new. We had a research report come out around KubeCon. Feel free to check that out. Lots of interesting information there. We interviewed over 500 different organizations to see how they see the challenges and the opportunities of working with data on Kubernetes, running stateful workloads, databases, stateful sets, persistent volumes, persistent disks. Some of the stuff we're going to be talking about today with our honored guest, who is Neil Creswell, the CEO of Portainer, normally based in New Zealand, currently joining us from New York. Neil, what's up? How are you doing?
Oh, I'm very good. Very good. It's awesome to be here.
Good stuff. So, like I said, you're originally from New Zealand. Can you tell us a little bit about your background and how you ended up in this cloud native space, also with data involved, and how Portainer got started?
Sure, I'll keep it brief because I can go on forever talking about this, but I am a career consultant in the infrastructure space primarily, and so have had a lot of experiences with VMware and enterprise storage in the past. Made the transition to containers around 5 years ago, I think, with the very early stages of Docker and trying to deliver a CAS type solution to the market through a public cloud provider that I was running at the time. And so got exposed to Docker, got exposed to Docker Swarm in the early days and trying to deliver this service out to the market. The market says, what is this API endpoint? It's meaningless to me. Where do I log in and deploy things? Where is the web UI? How do I pass this to my users? And basically at that point, there was nothing around. We hunted and looked and tried to find solutions that would be a user self-service front end for containers, and there was no such thing. So ended up creating Portainer. So yeah, Portainer has evolved dramatically over the last 4 or 5 years from a really simple Docker UI now to a full container-based application management tool. And our goal now is to make container technology available to everybody. So not just those who can afford to retrain themselves in Kubernetes and all of the other surrounding technologies, but as long as you know Docker on your machine, you should be able to use Portainer to do anything.
All right, very, very good. And you were also at KubeCon. What was your experience like there?
KubeCon was awesome. It was, obviously it would have been awesome. Would have been way better if there were 25,000 people there, but with the 3,500, it was not a cramped experience. So there was plenty of time to speak to people and really get to know people. And it seemed to me everyone was actually quite comfortable. A lot of people were comfortable, shaking hands and spending time chatting. So it was just a really good experience being able to actually meet people face to face for probably 2 years now. Was the last time I had an actual physical event. So yeah, really, really good. Some really good connections made, and I'm looking forward to following up with a decent number of people in the coming weeks.
Yep, I completely agree. Also had an amazing experience. With that in mind too, just so everybody knows, I'm sure Portainer is already thinking about this too. When one KubeCon ends, we start planning the next one. And so the CFP for the next KubeCon is already out and available. So if you want to apply for that, I can drop a link later on. But there's going to be tons of activity going on in Valencia, Spain, where that will be held next year in May. I believe it starts on the 17th and finishes on the 20th. Data on Kubernetes community will of course be there. We're already making plans to be there, to have an on-site event. Still debating whether or not it's going to be virtual or hybrid, hoping that we can go for hybrid to get folks together, physically speaking. But anyway, more news to come out that relatively soon. That being said, the title of today's talk, persistent disk or stateful set. Where did you get the interest in this topic, seeing, the dilemma that could be going on, making a decision about what's best if you're going to be making a deployment?
Yeah, so I'm spending a lot of time out there in the Kubernetes communities now. If you think about where Portainer came from, we were known as the Docker guys. And for us to rebrand, reposition ourselves and be relevant in the Kubernetes community, it means we need to actually exist in that community. So I've joined as many communities as I possibly can, and I'm engaging with people who are trying to get started with Kubernetes for the very first time. And what I came across is a sheer lack of understanding. And I don't know whether it's because they don't have underlying foundational knowledge of containers in general. They've just started from nothing to Kubernetes. I don't know what it is, but there was a sheer lack of foundational knowledge of containers and statefulness, and the fact that containers by default aren't stateful in any way, shape, nor form. And how to make them stateful isn't as simple as you might think. And there were a lot of people just making really flawed assumptions and saying, I'm trying to do X, I'm getting Y, and I can't understand why it isn't delivering what I wanted to do. And it was interesting having almost arguments with people saying, look, it can't do this. I know it seems like it can, but it can't. And people are like, well, no, it should just work. So I thought it would be a really good topic to discuss, to say how should you actually achieve persistence the right way, and make sure people are aware clearly the ways that you can do it, but probably shouldn't do it.
Very, very good. Very practical hands-on knowledge, because like you said, a lot of people, it seems like, okay, we're just going to jump into Kubernetes in the same way that some people rushed into the cloud without really understanding all the implications that came along with it. And we find that that's something too in our community. A lot of times people have the association of Kubernetes is stateless, everything's stateless. And then we're trying to, turn that conversation around, saying, these are the cases in which there's a lot of value being provided by running stateful applications, stateful workloads. So that being said, I don't want to take any more of the intro. So you can start sharing your screen, folks. Feel free to ask questions in the chat, either here on YouTube or on Slack. As well as we're not able to address all the questions in the live stream, we can continue the conversation in Slack later. So Neil, if you want to share your screen, go for it. I
will, and I'm not going to bore people with too many slides. I'm going to alt tab between slides and live demos.
Very good.
So please pray to the demo gods for me.
Will do. Well, we have to add. I think the demo gods will be on your side, because you can just explain. You dealt with an internet outage recently, which provided you the opportunity to explore a different part of New York.
Yeah, the building that we were working from, there's construction, and just before we went live, the internet went down and they were unable to restore it. So we literally ran to a WeWork, and so I'm currently sitting in a WeWork, and graciously they actually gave us the conference room for free for the next hour. So shout out to WeWork, awesome.
Shout out to WeWork, good stuff. All right, jump right in, go for it.
Okay, so I'm just starting off with what are stateful applications. Now, it's really interesting to understand what they genuinely are. So generally they're applications that need to persist the data whilst they're running, but also through the life cycling of the container-based application. Now, what that means is restarts, rescheduling, either rescheduling on the same host or rescheduling across hosts, updates, redeployment. So the data needs to be persisted. Also, stateful applications, they generally need a persistent identity. And what I mean by that is a host name. So they generally need a consistent host name. And they also expect to be started and stopped in a certain order. It's very, very difficult to have an application landscape that just starts and stops randomly. The database server really should start before the web servers, not the other way around. And so it's really important that you understand how to start and stop the applications in the order that they're going in. But what it is not is just a persistent volume. So a lot of people think I can make my applications stateful just by attaching a PVC. And it's so much more than that. Now, Kubernetes actually handles state in a couple of ways. So obviously the data is held in a volume, and it's connected through a volume claim. But it's actually really important that you make sure that the CSI storage driver you're using makes that volume available across all nodes in the cluster. If you don't, if you're just using something like host path or something similar like that, if the container is rescheduled or the pod is rescheduled on another node, the volume will actually be recreated and it'll be blank of data. So just because you have a persistent volume, if your CSI driver is not cluster scoped, then you be careful. Your data might not be there when the actual pod is rescheduled somewhere else. Kubernetes also handles states by allowing you to create host names that are predictable. And this is particularly evident in stateful sets, and I'll give you an example of that later. But without this, host names can change all over the place. And also the start and stop order for pods can be made predictable through Kubernetes state management. So this is how the four things it uses, how it handles it anyway. So how can you deploy stateful applications? Well, there's two ways. And which way you choose really depends on your application and your application's need for state. So the degree of state it needs. So you can go and use a regular old Kubernetes deployment, and you can attach a PVC, and you've got yourself a volume, and that volume will be persisted, and there'll be data written to that volume, and you can delete and recreate your application. And as long as you can connect to that volume, you're all good. But the problem with that is you will get random host names, and you'll also have a random start-stop order as well. So then there's the option of a stateful set, again with a PVC. And this is used if you need to persist your data and your application needs consistent host names and the predictable start-stop order. So these are the two options. Now, a lot of people think I can just use the deployment with PVC and that's good enough. It works, it actually persists your data, but that's not a truly stateful application. So it all seems very simple. You just use one of those two options, the deployment or stateful set. But there are actual complications here. Now, the storage access policies is where people get confused from what I've seen anyway. So there are multiple access policies, read, write once, read only many, read, write many. But the two most common are RWO, RWX. So read, write once, read, write many. Now, just because your storage supports RWX, and by that I mean something like NFS or any of the storage drivers you can see in the right-hand side there, does not mean your application does. So just because the storage supports it doesn't mean your application supports multiple read writes. An admin can actually manually set the storage access policy to something of their choosing. So you can actually go and choose a storage driver, let's say the AWS Elastic Block Store. It doesn't support read write many. The admin can say it supports read write many, and Kubernetes will go, okay, but then it will fail later on. Strange things will happen. So even though you can set the access policy to anything you like, don't. Make sure you only set it to the things that are supported. Now, why is this important? Because unless your application actually supports concurrent access to its data, you will likely end up in data corruption land. So you'll get this thing called last changed wins, where you've got two pieces of software writing to the same volume. If these two write a file of the same name, the first one will write the file, the second one will write the file, and the second one will override the first one. The first one has no idea that that's happened. If you are using applications that use disk locking technologies like databases, you'll often get a locking violation. So the first one will start, it'll get a lock on the database. The second one will start, it'll try and get a lock on the database. It'll fail and it'll come up with a locking violation. It'll sit there in an infinite retry loop, trying to get a lock on the database and will fail. Now, as an example, HostPath, the HostPath driver, does not support RWX, but you can set it. You can deploy an application like MySQL with two persistent volumes and two replicas, sorry, with a persistent volume and two replicas. Now, this is what I see most commonly requested in the Kubernetes community, especially the Kubernetes Facebook user groups. People say, I've got NFS storage. I'm trying to deploy MySQL with two replicas and it's failing. Why? My NFS supports the RWX access. Why is this not working? This is a really common use case. And if you do this, what you end up with is exactly as I said before. You'll have one of the replicas working perfectly fine, you'll see on the left-hand side, and one of the replicas failing to lock, like you see on the right-hand side. Now, I'll just show you this here in real time. So here I have a kube cluster here. I have the cluster configured with HostPath storage and its RWO access policy. I'm going to manually set it to RWX here. If I do this now, I can actually come in and say, create an application here. So test app, my SQL 5.7. I'm just going to persist var lib MySQL. 20 gig. It's going to be shared. And I want 2 replicas of this. And I'm going to deploy it. And this will now go and deploy 2 copies of the database with persistence, just a single persistent volume. They're both running. Just choose one randomly. So there you go. There's the first one here. So this one is open and connected fine. If I go to the second one now and go logs, there'll be locking errors. So they'll be unable to lock. There you go. Check that you don't have another MySQL process using it, unable to lock. So even though it actually lets you deploy it, because I've manually overridden the storage to say support multiple read write, both of them are running from Kubernetes perspective. They're both running, but MySQL is sitting there in an infinite loop saying, I can't connect, I can't get a lock, I can't get a lock, I can't get a lock. So one of them worked, the other one doesn't. And unless you know what you're doing, you will look at this and say, cool, both of my pods are running. It's working perfectly fine. I've got it load balanced across my database. It's only if you actually come in and interrogate, you'll see that it actually isn't working as expected. So this is one of the things that I see really common, where people just simply say, I've got NFS storage. I can't understand why I can't have two instances of MySQL accessing the same data and load balance between them. Now, what happens if we try the same thing, but on something like DigitalOcean, which has DigitalOcean block storage? Now, this does not actually support RWX. It only supports singular write. So if you try and manually set it to RWX, you'll get a different error. So unlike with the host path storage, where it lets you do it, the DO block storage simply will not allow you to do it. So if I try and manually set it to RWX and I try and deploy a multi-pod application that is accessing the same persistent volume, I'll get this multi-attach error because it simply will not let you do it. So that should be pretty clear now. If you want to persist your data, make sure that you don't play around with your access policies, and make sure that you have to have a replica of your data or a volume for each pod that you want to deploy. So each one can actually persist their own data, and then you have to take into account things like MySQL replication if you need to replicate the data, MySQL multi-master or master slave configurations to replicate your data. But what happens if you want to persist things other than state? So state other than storage, I mean. So you see here, if you actually use a deployment type, the host names that the pods and therefore the containers are given are randomly generated. So it's just a randomly generated string, and they will run across the nodes of the cluster happy. But if you put a node into drain mode or a node fails and it's rescheduled, you can see here that I had 5 pods running, so 5 containers here, and the bottom one here, its host name, it's running on node SK here. If I put that SK node into drain, it's rescheduled and spun up on another node, and I've lost that host name. So the host name is now randomized again, and unless your application is completely okay with that, having a random host name each time, you're going to get yourself into trouble. So if you need to have the host name state maintained, then a deployment type is not going to be your friend here. Now, most applications probably don't care about the host name. They just ignore it. You can use localhost or whatever else. But if it matters, then you have to know that a deployment will not persist your host names at all. So if you used stateful set as an example, they're always given the same consistent numbering. So from the first replica all the way through to the last replica, they're given very, very consistent numbering, and that numbering directly translates to the host name. And if I was to take a node offline, you can see here the node would actually reschedule on another host, but would keep the same name. Now let me show you that. So if I go to this node here, this is a DigitalOcean cluster here again. If I want to deploy my application, the WeWork internet is going a bit slow now. So if I want to try and deploy an application here, MySQL, I shall just use Nginx, make it quicker. And if I want to add a persistent folder, I'm just going to use /data because it doesn't actually matter for this case. And I want to do it shared. And I want to deploy. Oops, I wanted 5 replicas, but we'll change that. You see here, this will eventually run once you get the image. It has to pull it. Wait for the persistent volume and then pull it. In DigitalOcean, so it's sending the instruction through to the back end. And we'll eventually, there you go, attaching and deploy. With just my luck, this will end up on the node that I can't put in maintenance mode. But so here we go. So this is running on SH here. And you see here, this here is a stateful. So you've got the replica 0 is its name. So, and again, if I go into a console and do host name, you see here that's actually given replica 0 as its host name. So this is basically showing you here that you've got this really consistent name. Now, if I edit this and increase the number of replicas or change it in any way, it'll keep that same thing over and over and over. So we'll just actually do another one for you and show you what I mean here again. This time I'll just do a deployment. So this time we're going to do multiple replicas. And same thing, it'll go and connect to them. You see here, these have all got random host names. Now, if I just try and choose one of these ones, one of these nodes here, so S5 as an example, that's running 3 nodes. If I click on that one, depending on what's running on this node, I can potentially put it in drain mode. I can. So if I put this into drain mode, I'll put that as running on that one. So I can't do that one, I'll do the other node. SH. Okay, so I put this one into drain mode. That's going to evacuate those nodes that are running on there. And if I go back to my application, they will all be rescheduled with more random names. So I go back into here now. These will be running on somewhere else and they'll have random host names again. So you've got to be really, really careful here and exactly what I mean by this in regards to the random host names changing. So again, these are now all running on the same host because the other one's been put into drain mode and these are all now running random. Now, if I am actually creating another application here, so another application again, this one takes a bit longer because we're going to be creating a whole bunch of persistent volumes here. It just takes a while to configure. Just do Nginx again. So this time we want isolated and we want multiple replicas. You see here the Portainer there, I didn't enter the size, so it wouldn't actually let me continue. So just one of the front end protections. So here, when I've got this thing running here, so they expanded, you'll see there's 5 of them. And you see here, expand 0, so it'll start with the first one, and then it'll add the second, add the third, add the fourth, add the fifth, and as it scales, it will actually increase them out there, go 1, 2, 3, 4, 5, 6, 7, as you're scaling. So this is the 5 instances. Now just go back while waiting for that one to do it and just explain this. So this is the startup order here. So when you're with a stateful set, they always start the lowest number to highest and they stop highest to lowest. So you've got, when you first deploy your application, it starts with the very, very first node and it will go, you bring that up and running. Once it's up and running, it'll start the second, start the third, and keep going through this stage. If you do a redeploy, it does it in reverse. So it stop, and then restart them. Same thing if you're doing an upgrade. So that startup order really matters. If you have something like a MySQL multi-master or single master slave, and you need the very first one to be the master and the other ones to be slaves. So it actually matters a lot there. So if we come back here, I don't know what we're up to now. Okay, we've got 2 of them now. So you see here, expand 0, 1, 2, and you see they're going out and we're creating the volumes. So there's a volume per instance there. So this is again the correct way to do persistence across a multi-pod application. So this is just going to replicate out, and you'll see it's just going to keep going all the way to 5. So it'll just keep going through 1, 2, 3, 4, 5. So again, as it's running, it'll keep going as it's going there. And if you redeploy, as I said, it'll basically stop them in reverse order and then restart them back in the right order again. So really useful way to actually get a consistent host name. And again, if I come in and just choose any one of these ones, grab a console and host name, you'll see there you've got the host name persistent in here as well. So that's the primary information you need to realize in regards to stateful. So make sure that you are aware of the storage type and the access policy that your CSI driver supports. Don't change it unless you know what you're doing. So make sure that you don't try and force a square peg into a round hole. Otherwise you'll end up with data corruption or issues where the application thinks it's actually running where it's not running, and your users will have to go into triage mode. So don't change that at all. And also make sure if you need a true stateful application that you use stateful sets, not deployments. And again, it's amazing how many people think that they can get persistence just by using a deployment and attaching a persistent volume. Now, hopefully this thing should have already finished now deploying all of them. And I'll show you when we redeploy it. So they're all done now. So there you go. So they're all up and running here now. And if I was to take this node offline, which I can't because I've got too many nodes now in drain mode, but these would be rescheduled on another node now. And that would then keep the same name, the same host name as it reschedules. So really important thing to have there. Just with the storage configuration, again, you have the ability to set this access policy to either of them. We have here a link to the documentation. This is actually something you need to understand here. Now, this is that picture I had in the slides here. This is where you can get this thing from, this Kubernetes documentation. This is basically the source of truth, and don't do a config that is not in this table. That's basically the short version there. So you can see NFS, even though it supports read, write, many, and again, this is where a lot of newbies keep getting tripped up. Just because it supports read, write, many does not mean that you can automatically create a multi read, write replica of your application if your application does not support it. So I hope that's clear. So if you really need persistence, use stateful sets. Don't manually override your storage access policy. Don't assume your application supports concurrent writes. Absolutely never assume that. That's even more important if you're using databases, but even if you're not using databases, even if you're using just a normal front-end web server and your users are FTPing or uploading files through the front end, unless all of those know that file changes have been made, you definitely will end up with corruption. So don't assume that. Use Portainer. It will make your life far easier. And questions on this?
Awesome. Good. So a couple of things I just wanted to ask is that when you have been interacting with customers, as you mentioned at the very beginning, a lot of folks that have just, jumped from straight into like, okay, we got to be on Kubernetes immediately. Is there, we look at different things. When you have the conversations of why run data on Kubernetes, what are the sort of benefits that you generally propose to them as to why they should keep this in mind?
So there's still a lot of people out there, I think, who are a bit scared of running persistent apps on Kubernetes. They're not sure of how it's going to handle the workload. They're not sure how it's going to handle graceful shutdowns. So will it actually quiesce my database gracefully when I stop it, or is it just going to pull the plug and I'm going to end up with data corruption? There's still a lot of fear there. There's a lot of fear that says, how am I going to back up and recover these applications if they're running in Kubernetes when they're a virtual machine or a database service? Everyone knows how to manage that. You know how to snapshot your virtual machine to back up the data. You've got all of the VM integrations for data protection. If it's a cloud service, you know how to do this. And I think a lot of people get a bit confused around, what do I do when it's inside a container? It's like, well, hang on, the actual image is always stateless. The image can always be reconfigured. The config and config maps can be recovered. You know, the YAML can be saved and restored. Really, you're only talking about your persistent volumes. So how do you protect and back up those? But also, there's actually nothing stopping you from within your stateful application doing things like DB dumps. So just running the MySQL admin and dumping the database file out to a external location. So the main concerns people have is so I move my application into it. What do I have to change operationally now to ensure my data is backed up and protected, and all of those normal things that you'd expect for a critical data of record system, which is generally describes persistence. And again, yeah, persistence has two levels, right? Data record and just transient data. So I still need a persistent, but it's transient, and then data record. And data record is where people really freak out.
Speaking of freak out points, because that's precisely it. Is because one thing we talk about is what is running data on Kubernetes, how is it done, but then the other question, like I said, of why. And so the alarm bells start to ring of, we don't have the technical staff that have the skills to be able to do this. This is going to be a cost problem. Are there any sorts of other freakouts that you seem to be encountering when you interact with customers?
I suppose the biggest one is when you've got stateful applications. Yeah, everyone's quite now comfortable with the whole GitOps paradigm and fail forward, fail back, right? So I'm going to put a change live in production through my CD system. So a dev commits through magic, smoke and mirrors. A few minutes later, that change is live in production. If it breaks, the dev can actually revert their change in Git, and then 5 minutes later, the change is now reverted in production. That's all well and good, but when you introduce stateful application into that thing, what do you do when you've got schema changes? You can't just roll back. So I think that's still some of the fear factor there is if I'm going to go stateful, can I do stateful applications, and can I still do GitOps, CI/CD, roll forward, roll back? Because once you roll forward, if you make a change and the data is persisted, how do you then revert that? It's not as easy to just roll back. So that's where I think people are saying, well, hang on, is GitOps a thing only for stateless applications, and do I need to be more traditional for stateful, or can I do something in between where I can roll back my data as well? Can I integrate with third-party backup vendors to recover? So that, I suppose, there's also confusion there. It just shows it's still very, very new, or very early days for statefulness.
I think we can agree on that, and that's what we see. But it's promising, and we saw this in the research report that and we see it in other reports that have been coming out too, that there are a lot more folks that are running stateful applications, stateful workloads than perhaps we might realize. They're not necessarily making it visible. We're not really sure about that, but once again, this is our job as a community to keep these things out in the open. And one of the things that seems to be coming out in the open a fair amount, I'd like to know your experience about this, is what's your experience been using operators? If you're using them, for what purpose? Do you think that that's the primary solution right now we have for running data on Kubernetes? What do you think about that?
So I don't have that much experience using them. However, I've understood what they are now, and I genuinely think they are going to be the painkiller for this. Because if you think about something like a Helm chart or a manifest file, that's simply a way to get the application running. It doesn't actually help you in any great way configuring the application for multi-cluster replication or correctly configuring it. It basically it's the vendor saying, here's how you deploy our app, not necessarily how you configure it. Whereas an operator moves it more of a managed service-esque type solution. It's actually the vendor saying, not only this is how you deploy the application, but this is how you deploy and configure the application for best practice. So for example, the operator for MySQL, that is amazing. You can say, I actually want to have a multi-master MySQL cluster, and it will go and configure it for you, including all of the replication, everything, the whole thing. So you don't need to know how to configure MySQL correctly for multi-master replication. The operator will do that for you. The Helm chart does none of that for you. You will deploy it, and you need to then log in and configure everything. So that there's a huge difference there. So I think operators, especially in a stateful world, are going to take away a lot of the risk for the application vendor to ensure that it's configured in a correct way. Because if it's configured incorrectly and they lose data, you only lose data once, then you've got a serious problem on your hands.
Yeah, nothing, and that once again, the risk is of losing that data is, I think, why there's this sort of aversion to, okay, I don't want to put myself in any sort of situation where that might come up. Now, we do have a question from someone in the audience, Rich, which does touch on this. You just mentioned multi-master. He asks, for deploying MySQL, why would you not choose multi-master in a replica set, Percona, I guess, versus master with read-only replicas on other nodes? What about these new sharded MySQLs like Vitess?
I've not used the sharded MySQL ones, but why would you use multi-master versus single master multiple replica? I think it comes down to latency, so to the actual response time. But for me personally, whenever I've deployed MySQL in a load balance environment, I've always done it multi-master. I've never actually done it master multiple readers. I think the main reason that people do that is for data warehousing. So they actually use the one master node for their actual read-write transactional, and the read-only ones they use for data warehousing queries, or to clone data out for non-prod environments. But me personally, I've always used multi-master if I've ever needed to actually have a stateful MySQL database inside a cluster. Okay. The sharded ones, I've played with things like Crate and Cockroach, which are genuine scale out, true multi-master, and those things are amazing, and they're definitely the future of databases, absolutely.
Okay. Good. Let's see. Following up with a couple other things. So if you had we ask this to all of our speakers, if you had a magic wand, what would your wish be to make running data on Kubernetes easier? Because we talked about operators. Is there anything beyond that we could be more ambitious?
I think having a proper seamless integration to snapshots and backups, so that when you actually roll back to a previous config, your Kubernetes makes it very easy to roll back. I really do think that the rollback for a stateful application should also include a rollback of its data state as well. So whether you can do that, because that to me is, I think, the biggest barrier at the moment is, once you make changes and write changes into your database and schema changes or whatever else, man, that's so hard to revert that. You're actually restoring from a backup. So, as you push a change through your pipeline, if you're actually updating the application, redeploying it, or making a change, if there was a native way to snapshot and roll back as part of the rollback command, that would be gold. I think also making it far easier to export the volumes in a schedule scripted way for external backup as well. So whether there was a command to stream the volume to a third-party location, so that you've always got a off-cluster copy without having to rely on your storage vendor to do that for you. So I think if I had a magic wand, that'll be the two things that I'd like to see.
Okay, it's good. Like as you said, this is a space that's getting more and more attention, but we still feel that we are in early days on this. So there are still things that have yet to be decided, and this is why we've been asking people in the community what's their experience been, whether it's been building operators, because that seems to be the case for a lot of folks out there, is building an operator, but then what are the steps that are necessary for that to happen? Do you have the staff that can properly execute that without taking too much time away from your customers? Thinking about, and because you are as someone in the position of CEO, when someone comes to you, when you're explaining this to a customer and they're thinking, okay, we have the expression in the US, you're in New York, if it doesn't make dollars, it doesn't make sense. What are the financial benefits of running data on Kubernetes?
I think the main thing is it really does let you get more into that whole microservice. So rather than having a singular large database service or server somewhere with multiple DB instances, being able to have multiple smaller increments with the database tied very closely to the front-end application that's actually using the database. So, making it far more self-contained. That means that you take away the need ever for maintenance windows on a single large server. It makes it far more cost effective to scale. It's far easier to adequately define the resource limits and quotas and all that kind of stuff. So it just seems a far more efficient use. I suppose the only negative might be license. If you're using a licensed database, then obviously you're going to have far more of them versus a smaller number. But there's those kind of complications. But yeah, for me mainly, it's more around efficiency and also truly enabling microservice where the database can be entirely consumed by the front-end application as opposed to a shared database instance over here.
All right, very, very good. Good to keep that in mind. So we are getting towards the end. Is there anything else you'd like to mention in terms of news about Portainer? You're hiring, you're going all over the US right now. Next steps. Oh, we just got another question. So before we get to that, another question from Rich. Thank you, Rich. Have you had to troubleshoot operators much, and what was helpful there? Have you ever had to just start over from the beginning and restore everything?
I have often had to restore everything because we use Kubernetes ourselves in our own internal testing environment for building Portainer, and I am breaking my environment almost weekly, it seems. And I have almost given up troubleshooting now Kubernetes. I simply just delete and redeploy it. It's quicker to redeploy it. It's quicker to spin up a new cluster. I do most of my testing on either DO or Linode, and it's simply so quick to delete and redeploy, and so that's the model I use. So I very rarely know, that might just be that I'm lazy and I hate triaging Kubernetes issues, but I always just simply build a new cluster, redeploy my applications, and I'm up and running. Have I needed to triage operators? Not yet myself, no. Just one thing, by the way, that's really important in regards to stateful applications, right? So if you think back 3, 4, 5 years ago, right, there were expert storage consultants inside IT who, whenever someone in the business says, "Hey, I'm deploying a new application, it's going to need a database," and they went into some very detailed Excel-based analytics and calculations and formulas on how many IOPS do I need, what kind of latency do I have. We had the Exchange sizing tools, the MS SQL sizing tools. It says what RAID array, how many spindles do you need. All of that stuff seems to have been forgotten, and I don't know how or why. All of the thought that went into how do I ensure that I have a storage subsystem that is sufficient to deliver the level of latency that my application needs, the level of IOPS and throughput that my application needs. There was a huge amount of thought went into that to make sure that the backend storage subsystem would be suitably sized to make sure the database would deliver the level of performance that the application needed. A lot of that stuff's been forgotten these days, and I think that unless we figure that out, you're going to find that stateful-based applications are biting people because they're simply underperforming because there's just not been the sizing of thought put into it. So people say, "I've got my database up and running. It's persisted. It's performing really badly. Why? What's going on? What's wrong?" And it could be, well, hang on a second. You're running on some nasty backend storage, so you can't run this on NFS. Everyone knows you don't run databases on NFS. You just don't. But from a dev who's using Kubernetes, maybe they don't know that the actual storage driver that their admins has configured is on NFS. They don't know. So they just go and deploy an application, make it stateful, and it performs terribly. So there's still, even though Kubernetes and containers in general has created this almost this wall between, I don't need to care about the infrastructure, I just want to deploy my app. When it comes to statefulness, I don't think that wall is as solid as we'd like to believe. You still need to understand what's under the covers. Is this thing going to be performant enough for my application? Do I need NVMe backed storage as opposed to SATA backed storage? And how can I ensure that I'm getting the right level of performance? There's kind of no way of measuring or tiering that in Kubernetes today. You can't say this storage has been benchmarked by the Kubernetes layer and can deliver X. There's not that at the moment. Sure, you can set limits and reservations, but unless you know what the backend can actually provide, you're in dire straits, and that's kind of another area that really needs careful thought.
Plenty to chew on there. I guess also is there anything else, perhaps reflecting on maybe some of the things that you saw in KubeCon? Are there things that you feel are not getting enough attention in addition to what you mentioned?
I think the ease of use is actually semi being forgotten. Now, I'm probably saying that because I'm biased, because our whole goal in Portainer is to make Kubernetes really easy to use. So maybe I'm biased, but Kubernetes is getting now so wide. Its reach is so wide now. It can pretty much do anything that you want it to do. But by going wider and doing more and more things, you're actually adding really high layers of complexity now. The fact that you have a tool that is basically a Swiss Army knife, you can do anything. How do you know which particular blade you need to pull out of that knife? So the wider it goes, the broader scope that Kubernetes goes, the more things it touch, the more things it can deploy. And operators, I think, are actually in some way making this worse. They're going wider and wider and wider. The actual mental load on the user increases quite dramatically. So that's one area I think is kind of being almost forgotten. It's like we're actually adding quite a bit of extra complexity here. How do we make that go away?
And that's one of the arguments as well too for running data on Kubernetes is simplifying by having everything in one stack.
Correct.
But then, like you said, by doing that, you resolve one problem and potentially create another. So how do we then simplify the thing that was supposed to simplify, but actually made it more complex?
Yeah. It's definitely no silver bullet, but it makes it so much easier. When you can actually say, here is my application. It's in this bubble. It's completely portable. I can now measure and manage and monitor this application in totality. If this application doesn't perform well enough, I can move it somewhere else that's more performant. That's far easier than having to worry about a shared service over here. And I've got some system coming into my front end applications, back out of the cluster to potentially some middleware or to another cluster, back to somewhere else with the database. Having it all self-contained makes it really nice and easy and portable.
Yeah. Very good. Well, thank you very much for taking these questions as well from the audience. And I really like your vision on this and identifying the problems. But also the thing is that there is progress being made, and we see that, once again, we're approaching live stream number 100. So we've had over nearly 100 people come on and share their experiences of what it's been like working with running data on Kubernetes, and we see an increasing ecosystem. In the beginning, more focused on databases and storage, but now branching out into other areas such as data streaming, even security, different things that are coming in there, cost optimization. So it's really building out and getting more robust. But as we said earlier, there's still a lot of ground to cover, and we're somewhat in early days, which makes it exciting because there's uncertainty. Now that we are getting towards the end, though, is there anything Portainer news related that we need to be aware of, stuff that's coming out, anything that's going on, hiring, firing, anything? Hopefully not firing.
Definitely never that. So we actually released a version of Portainer, the Portainer CE 2.9. We released just before KubeCon with what we like to describe as an incredibly awesome Kubernetes experience. So if you want to get started with Kubernetes and you want a far gentler on-ramp to the technology, take a look at Portainer. We have Portainer is a commercial open source company, so we have an open source version and a paid version, and the Portainer Business Edition that's due out very, very soon in the next 2 weeks. We will be offering a 5 nodes free forever license for that one. So for those people who actually want to get started with our commercial variant, which adds additional capability around audit and governance and security, if you want to get started with that, look out for our 5 nodes free forever license coming to you in November very, very soon.
All right, very, very good. That's good to know. Last but certainly not least, we have a tradition in our community that while the talk is ongoing, we have someone who's lurking in the shadows, and he's creating an artistic summary of all the things that have been going on. So let me know when you can see my screen.
I can see it.
Good. So we've got, obviously, there was a lot of stuff that was mentioned in there, and hopefully we can take a look at the slides later on because some of the folks were asking about that. Very hands-on, very practical. The demo gods were on your side today, so that was good to see as well. Going back and forth between the slides, very, very well explained. And precisely as you mentioned, is that this onboarding experience for lots of folks getting into Kubernetes is so overwhelming that it becomes a turnoff. And I have friends that have done DevOps, that have done big data, that have done all these other things. And when it comes to Kubernetes, they're like, nah, this is not for me. And so it's really refreshing to see that there are folks in the space that are in the ecosystem that are taking those things seriously. As much as we talk about technological stuff, a lot of it is empathizing with people and their struggles and difficulties and frustrations. And in order for these things not to be so siloed in a smaller group of individuals, it needs to be democratized and broadened out by becoming simpler, or as some people say, by becoming a little bit more boring. Not the word that we would precisely like to use. More comfortable, I think, would be better to say than boring. So anyway, Neil, thank you very much for your time today. It was a pleasure. Great interaction with the audience as well. Shout out to everyone who was asking questions. If you want to continue the conversation, feel free to do so in our Slack. If you're not subscribed already, just hit the subscribe button. It's really easy. We'll have another live stream coming up this week and plenty more action as always. So Neil, enjoy your time in New York and the rest of your time in the United States, and hopefully talk to you soon. All right.
Thank you.
All right. Take care.
See ya.
Bye, everyone.
Bye.